Hey there, guys. This is Dr. Glenn, and welcome to our Facebook Live today. I appreciate you being here. And today we're going to talk about something called your DNA and your brain. And what it's actually called is your DNA is technically called your genomic profile. So it is, everybody is just a little bit different. We're all unique, and that uniqueness is based on our personal DNA. Now, there's a lot of things that are very similar, but there are little tweaks and things like that, uniqueness and things that are particular to just you and no one else. And when you start personalizing healthcare, and that's really where we are. The 20th century was sort of everything changed, and you started going after bacteria and you started the use of drugs and things like that. We'll come back to that in a minute. But in the 21st century, what we're seeing is a real personalization of healthcare. And for these chronic diseases that we have now, especially, cognitive decline in all of its different forms. And just to remind you, if you don't remember, or if this is your first time with us, there is an umbrella that we call dementia. Dementia covers all forms of cognitive decline, everything from traumatic brain injury, like you see like in football players and things like that, all the way to Parkinson's disease. It includes Alzheimer's and Lewy body dementia and all of these different types. They all fall underneath the umbrella of dementia. And they're all just a little bit different. And how that applies to you is going to be unique to your genomic profile or your genes. Now, when you look at trying to treat someone for one of these complex, multifaceted diseases, you have to start personalizing it and individualizing it. So we have just recently, and I mean recently, I mean like as in this year, been able to get DNA profiles of the things that affect your cognition. And I want to take just a moment as we're getting going here, and I want to bring up this little thing right here. This right there, Intellex DNA. Maybe make that a little larger so you can see it. Uh, as a matter of fact, this is so new that right now in the state of Florida, there are only 5 of us doctors that have been through the training to use this. We just got access to this back in February. Uh, this profiling and putting together of DNA was actually spearheaded by a doctor in Austin, Texas, named Dr. Sharon Hausman Cohen up at Harvard, and and this is a completely new way of looking at how you apply treatment to people individually. So you'll notice that I've got my little over here on the over here on the side of my screen here. I've got my little badge there because we here at the Carroll Institute, we are an Intellex DNA authorized clinic. So I'll take that off now. All right, so let me explain a few things about genetic profile. When this is not your 23andMe or something like that that tells you, what your genealogy is or what your heritage is, and when I think of this commercial, maybe you've seen it. You got these two guys and they're dressed up in lederhosen because they've been told their whole lives that their family was German, and then they run their 23andMe or whatever it is, and they come back, and the next scene they're both dressed in kilts and Argyle knee socks because the DNA showed that they're Scottish. Well, that's great for doing genealogy and stuff, but that's not what we're talking about here. What we're talking about is things like your ability to detoxify, your vulnerability to Alzheimer's and dementia, your vulnerability to stroke, and all types of things like this. And I'm going to show you some examples of it in just a little bit. But when we look at personalized DNA, we look at something called SNPs. And what SNPs are is they are singular nucleotide polymorphisms, if you don't ask me to spell that. But It's the way that a gene can be tweaked just a little bit that will be unique to you. So there's certain genes that you don't mess with, like where your ears are and where your nose is and stuff like that. But then the shape of your nose and, mine's kind of wide and some people have long and skinny ones. Those are based on uniquenesses of those genes. So when you look at personalizing your treatment, then you have to look at the uniqueness of that to you. So what genetics tells us to do is it tells us exactly how to best treat you for whatever's going on. Now let me contrast that to the way healthcare sort of became modernized in the 1940s. If we'll go back just a little bit so you'll understand how this has progressed. Back in the early 1940s, the number one cause of death in the whole world was infectious disease. And we've heard a lot about this growing up and so forth. But in the early 1940s, uh, the infectious disease was the number one cause of death in the whole world. And what happened in 1942 is a woman went into Yale Hospital and she had a pneumococcal pneumonia infection or pneumococcal infection that we would call pneumonia. And the expected outcome back in the 1940s, if you had an infection like that, is that you would die. That was what was expected. And if you didn't, well, God smiled on you or you got lucky or something happened. Well, when this woman went into the hospital, she was the first person in recorded history to ever be given what we now call antibiotics. And what happened is she didn't die. And what this did is this completely changed everything that we know about the delivery of healthcare. So they came up with this antibiotic and they had this bacteria over here and what happened is the antibiotic would come over and attack the bacteria and the person would not die. So what happened is you developed a drug that would treat a thing like a bacteria or a virus or something like that. We have that now with the coronavirus and our vaccinations and so forth. And for those things, this system works pretty good. But the problems that we have now are not, you don't take a drug to attack something. This is why, recently we've had I won't mention the name, but if you've been watching the news at all the last few months, you know that there's been a new drug out that the FDA got strong armed into releasing provisionally, a provisional approval. It was not actually approved for treating Alzheimer's. And the problem is that it's exceedingly expensive and it doesn't work. And 40% of the people who take this drug end up with swelling and bleeding in their brain, and that's not good. What we've learned over the last several years, especially pioneered by Dr. Bredesen out at UCLA, is that in order to treat cognitive decline, you have to be able to, one, identify what's causing it, okay? And then you have to be able to personalize the treatment for that particular person. So when you start running DNA, you can see how you treat that particular person. And so let me just show you, I've got some things here today to show you. We have several different panels. This happens to be one of the panels that we can run to see genetically how you're put together. And once you know that, then you can know how to best treat. Now, this panel right here has to do with mental wellness. This is a great panel that we like to run. This for people that are having cognitive issues as well as maybe depression, anxiety. This even is good for ADD and ADHD, and even for kids on autism spectrum. Things like that, autism spectrum disorder. This is a great panel, and when you go in and you see what's going on, then you know where you need to go to work on it. We have other panels that are specifically designed for just cognition, but you can see all the things that are included in here. If you go down, you got addiction, ADHD, anxiety and stress, attention, focus, Benzene has to do with pesticides. BDNF is how you exercise, brain-derived neurotrophic factor, and so on. You see heavy metals. Histamine has to do with inflammation, and homocysteine as well, and so on and so forth. So let me show you when we start looking at DNA, what we end up is we figure out exactly how to treat somebody. So let me show you the one. This was the one that just really sort of just got my attention in the very beginning. I know it's kind of hard to read. I'm gonna make it a little bigger there if I can. Pull it down here. Let me move over and I'll make it a little bigger. Okay, this right here, this particular patient came into us and we were working on cognition. And this particular person, uh, avid tennis player. I mean, out playing several hours of tennis every day, the best tan. I mean, this was a better tan than you could have gotten if you'd gone to a tanning salon like 4 days a week. Super tan, very fit, the whole thing. Looked at the blood panel profile, which is where we start with everybody, and the vitamin D levels were just like in the basement. And of course, we all grew up, right? Well, I'm going to make it a little smaller so I can sit back in my chair properly. All right. So we were told growing up, if you want vitamin D, hang out outside, take your shirt off in the sun if you're a fella and all of that. And, you'll make all the vitamin D you need. Well, this person is out in the sun several hours a day playing tennis, having a great time. But the vitamin D levels were just like, I mean, like really low, dangerously low almost. Looked at his DNA, and what you can see, let me make this bigger again, I'll myself out, is that this particular person's DNA was set up so that if you look at the bottom right here, variants appear to correlate with a decreased ability for the skin to make vitamin D from sunlight. And he has two SNPs. That is a variation. So this particular person could hang out in the sun all they wanted and they'd still have low vitamin D. They can play tennis 8 hours a day and they're still going to have low vitamin D. Now, what makes this significant for your brain is that vitamin E is not actually a vitamin. It's a steroid hormone. It was called vitamin D because they didn't know what it was when they discovered it. But it's actually a steroid hormone, and it is very, very important when it comes to not only your immune system. Hello, we're going through the pandemic. Your immune system's like really important right now, but it's also a huge player in the quality of brain function and your ability to create neurotransmitters and synaptic chemicals and things like that in your brain. So you have to have good vitamin D levels. Well, when you ran the DNA, you find out that this particular person did not have the actual ability to make vitamin D by being outside. So what do? You have to supplement it. And so once you started supplementing it properly and thinking that instead of thinking you're going to make it being outside, then the vitamin D comes up, the cognition starts to work better, your brain starts to function more like it's supposed to. So let me show you a few others. I just pulled a few out here. When we look at genetics, we actually are looking at between 800 and 1,000 genes. Those are the ones that are involved in cognition and so forth. So there's a lot of stuff going on there. But this particular one I pulled out because it has to do with celiac. Now when I was in school, what we were taught is that if you were celiac, and that's actually a rare uh, condition, genetic condition, then you have a genetic problem with gluten and you can't eat gluten, which means, if you eat it, I've got a colleague out in Dallas, and if he gets exposed to it, even just like, you know, a tiny exposure, he's 911. He's got to have an EpiPen and he's got to get to the ER as fast as he can get there. We now are able to look and see that there are people that have certain genes that don't make them celiac, But what they do is they make their immune system more sensitive to being exposed to gluten. Now, so this person may not be celiac, but they still need to stay away from gluten because even though they're not celiac, if they get exposed to it, it will ramp up their immune system. And when that happens, you get an inflammatory response. And inflammation, of course, is not only bad in your joints and things like that, but inflammation is one of the number one drivers of cognitive decline. So this way we know how to tailor a person's diet to match exactly what they need. Not a guess, okay? Not saying, oh, let's just do keto or let's do Mediterranean or let's do this or that or whatever. But we've actually got a lot of different panels like this that are in our overall panel that can tell us how to fine tune the diet exactly to what you need. Okay. Now let me show you another one that we all know that exercise is important. Exercise is important for your brain because when you exercise, you should be making this stuff called BDNF. BDNF is short for brain derived neurotrophic factor. And BDNF is like fertilizer for your brain. It helps you to grow new brain. And of course, when I was in school, and your doctor as well, and they're still teaching this in med school and in neurology classes, you can't grow new brain. Well, yeah, you can too. Certain parts of it still have stem cells throughout your entire life. And this BDNF stuff, it helps you to actually fertilize, if you will, those stem cells that are in your brain. Your hippocampus is one part of your brain where you make a lot of memories, and you actually have stem cells in your hippocampus that can become new cells to keep regrowing that part of your brain. And BDNF is like fertilizer for that to help it happen. And BDNF is supposed to be made when you exercise. But if you have a SNP, then you have to tweak your exercise to compensate for that SNP. And that's what we do here in the office is we look at this and we have our coaches and we have a nutritional coach and an exercise and sleep coach, and they know exactly how to take these things that you need and fine tune them for exactly what will work best for you. So BDNF, you got to look at that. There's another one here that I like to look at. This one is brain ischemia. And I don't know if you know what ischemia is, but ischemia is when you lose oxygen to tissue. In other words, it's a stroke. The example of ischemia that almost everyone is aware of is a heart attack. When you lose oxygen to your heart, stops working. That is an ischemic event. When you lose oxygen to a part of your brain, you have a stroke. And we can look now at panels that have to do with brain ischemia, and we can say, oh, you are vulnerable to a stroke, and therefore you should take this supplement or this supplement where somebody else might not even need that. You know, I have so many people come into the office now and they come in with this long list of supplements that they're taking because what's happened is they're just hoping to get lucky. They've seen an ad on TV or their next door neighbor told them or their best friend growing up told them that, oh, you should take this and you should take this. And I took it and my brain woke up and all this kind of stuff. That's great if that's what you need. See, what your DNA tells us is not, you're no longer guessing. When I can look at your DNA, I can tell you exactly what you need. And that's personalized care. Instead of saying everybody should take this, no, everybody shouldn't take that. The people who need it should take it, and the people who don't need it, don't spend your money on that. Buy better quality food. All right, so that brain ischemia, that's it. And I know a lot of people that, most people fear a stroke more than they fear anything else. And boy, just being able to treat people specifically so that we can help to minimize the event of stroke is a great thing. The next one I wanted to show you that I pulled out here, and remember, we do like our panel list is like this long, so I'm just showing you a few things, but these are very important, and they have to be personalized. This thing about heavy metals and detoxification. One of the things that we are seeing more than we ever thought we would see is how much heavy metals. Now, heavy metals, when it comes to the brain, we're talking about mercury, lead, cadmium, arsenic. A lot of people aren't aware that arsenic is actually a metal. Okay, it is. Aluminum is a big one. These metals, they can get into your brain, and when that happens, it's not good. Other things can get into your brain as well, like mycotoxins, things like mold and bacteria, things like that. Those can get into your brain also. When they get in there, you got to get them out. Well, you can't detox everybody the same way. There is no best detox for everyone. Why? Because genetically you are unique. So if we're going to, let's say you come in and we find out that you've got mercury fillings in your teeth, or you grew up, I don't know, in a coal mining town in Pennsylvania or some deal like that, and you've got heavy metal exposure. So you've got mercury in your brain, and we need to get it out. Now, there are ways to do this. There are herbs and things like that that will chelate or bind onto those metals and pull them out. But your liver has to be able to process that. So this particular SNP, for this person right here, they have a SNP that prevents them from using something called glutathione. It's a kind of a complicated chemical, but glutathione helps you to detoxify. So if we ran a heavy metals blood test on a person, and we found out that they had mercury in their brain because their fillings have been gassing off, for years, and you wanted to pull that out and get that mercury out of their brain so you could fix their cognition, well, you'd have to take into account that they don't have the access to glutathione that's needed for that. So you'd have to add that in, because if you didn't, you'd pull the mercury out of the brain, but your liver wouldn't be able to get rid of it. So what would happen? It would go get distributed and stored away somewhere else, probably in your fat somewhere, and sooner or later it'd find your way back into some place we didn't want it. So let me get rid of that. So when we look at helping people with cognitive issues, actually, this doesn't apply to just cognitive problems. This can apply to autoimmune disease. It applies to thyroid, which is a huge problem, thyroid problems. We even run panels for propensity towards diabetes and obesity and macular degeneration. You could have an autistic kid. You could have somebody who's suffering from anxiety and depression. Your genetics play a part in everything that you do and in who you are. And therefore, they play a part in how to best treat you. So I hope that this has been helpful today. Realize that 21st century healthcare is completely different than 20th century. Did I say that right? 21st century is completely different than 20th century. The problem that we're finding right now as we transition from 20th century healthcare into 21st century healthcare is that our system is designed to give you drugs to attack things like pneumonia. And you know what? If you have pneumonia and you get the right antibiotic, man, does that work good. That is fantastic. But if you have a problem that is more complicated, complicated doesn't mean it's more dangerous or more deadly. Pneumonia is pretty deadly if you don't have an antibiotic, but it is a simple problem. Simple. A bacteria causes a problem, you die. Cognitive problems, heart disease, cancer, Alzheimer's and other forms of dementia. These are complex problems for which there isn't a drug. You have to find out what's causing it, and then you have to ideally tweak the treatment to match exactly the way that person will respond. And that's what we're now able to do with DNA that we were never able to do before. So these are really exciting times. I hope this has been helpful for you today. Thanks for being here, and we'll see you next Tuesday at Dr. Glenn Live. Have a great day.